All right, let's take a look at one last example. A bullet is fired straight up in the air at a speed of 900 meters per second. The equation relating its height as a function of time is going to be h is equal to negative 4.9 t squared plus 900 t plus 2.4. The first question it asks is, how long does it take for the bullet to hit the ground to the nearest tenth of a second? So we can tell, like in the previous questions, that we're looking for time, and when it hits the ground, that's going to be when the height is 0. So I'm going to replace the height with 0 in this equation, and I'm going to say that 0 is equal to negative 4.9 t squared plus 900 t plus 2.4. Now, when I'm doing this, I can tell that this isn't going to be very nice to factor, so I'm just going to go back to my quadratic formula. I'm going to say that t is equal to the negative of b plus or minus the square root of b squared minus 4 times a, or negative 4.9, times c, which is 2.4, all divided by 2 times a, which is that negative 4.9. This is going to give me approximately negative 900 plus or minus 900.261, all divided by negative 9.8. And then from there, we're going to do the positive and negative versions. So I'm going to have 1 is going to be where t is equal to the nearest tenth of a second. Well, that's negative 0.026, so that one doesn't make any sense. So let's take a look at the other possibility. It's going to be t is equal to 183.7, which is the one that's going to make sense. So I can say the bullet hits the ground 183.7 seconds after it is shot. When it says, what are the maximum and minimum velocities of the bullet? Well, if you think of what's happening with the bullet here, we have the bullet, it's being shot, and then it's going to go up until it reaches its maximum height, and then it's going to come back down again and eventually hit the ground. So we can see that's going to split into two sections, when it has the positive velocity and where it has the negative velocity. And remembering that it was shot not from the ground, it was a height just above the ground. That's how we know that the initial t-intercept was not at 0. So when it says what are the maximum and minimum velocities here, well, I know that the velocity is going to be h prime of t, and given my original equation, that's going to give me negative 9.8 t plus 900. So what is the maximum velocity? Well, the fastest the bullet is ever going to go is right after it is first shot, because that's going to be its highest speed, and it's just going to get slower and slower and slower, or reduce velocity until it turns around at the highest height it's going to hit. So I'm going to say that for the max velocity, that's going to be the instantaneous velocity at 0, which is just going to give me 900 meters per second. When I'm doing the minimum velocity, that's going to be when it's going negative, and then it's going to speed up towards the ground, and right as it hits the ground is going to be that minimum one, which we know is at negative 9.8, where when it hits the ground is at 183.7 seconds. We solved that in the last question, which is going to give me negative 900.26 meters per second. Now, it logically makes sense that the max velocity and the min velocity look so similar because when it was first shot, it was very close to the ground, which means that as it's going up, then it's going to have approximately the same velocity as when it came back down again. The only acceleration that's happening there is gravity. For part C, it says, what is the velocity of the bullet after 60 seconds and what direction is the bullet traveling? Well, the after 60 seconds or at 60 seconds is going to be the velocity at 60 seconds is equal to negative 9.8 times 60 plus 900. When I put that in, I'm going to get 312 meters per second. When it says, what direction is the bullet traveling? We know that the bullet is traveling upwards. Because of the positive velocity. This bullet is only, because it was shot straight up, only going up and down, so you don't really have to worry about the left and right. When does the bullet reach its maximum height to the nearest tenth of a second? Well, what do we know about the maximum height? We can see that it's going to come upwards, hit its maximum height, and then come back down again. And right at that turning point, we know that's when the velocity changes from positive to negative, which means that the maximum height in this case is just a fancy way of saying the velocity is equal to 0. So when does it reach its maximum height? Well, that is when negative 9.8 t plus 900 is equal to 0. Or when negative 9.8 t is equal to negative 900, or when t, when I divide both sides by negative 9.8, is equal to 91.8 seconds. And last but not least, what is the maximum height of the bullet to the nearest meter? When it's actually asking for height, remember that's where we go back to our original equation, that h of t is equal to negative 4.9 t squared plus 900 t plus 2.4. So we know that it reaches a maximum height at 91.8 seconds. So that's what I'm going to use. Negative 4.9 times 91.8 squared plus 900 times 91.8 plus 2.4. And to the nearest whole meter, this is going to be at 41,329 meters. The maximum height of the bullet is 41,329 meters. And that's it for lesson 1.